Hi, in this video we're going to be working on converting from molecules to grams. So I'm working out of Julia Burdge 3rd edition chemistry textbook, and I'm working off of page 92. So if you'll look at page 92, there's this handy flow chart down at the bottom. Think of it like a map, and we're going to follow the map. We're starting at molecules over here, which is a kind of particle, and we want to get back to grams. So we're just going to follow along the lines, the roads here of the map, and do what it tells us to get to the next box. So the first road says to get from particles back to moles, divide by Na, that's Avogadro's number, and the second one says to get from moles back to grams, multiply by molar mass. So that's what we're going to be doing. So starting at our starting amount, which is 7.92 times 10 to the 19 molecules of carbon dioxide. I'm just going to write that again. 7.92 times 10 to the 19 molecules. Make sure you write out the whole unit, because if you just write molecules, then you're not quite sure if you're talking about carbon dioxide or something else, so write out the whole unit. So that first step says divide by Avogadro's number. So reminder, Avogadro's number is 6.022 times 10 to the 23rd. Now the units in Avogadro's number is where students get the most tripped up. They think it has units of moles. Well, Avogadro's number is a number of objects per mole, just like dozen is 12 objects per dozen, whether these objects are erasers or pencils or donuts, is 12 donuts per dozen. We wouldn't say 12 dozen when we're only talking about 12. It's 12 objects per dozen. Same thing here. Avogadro's number is objects per dozen. And now to know what object you're looking at is just whatever we're looking at. Here we're looking at molecules. Those are our objects. So the answer is molecules per mole. And that is our unit. So it says to divide by it, or you can multiply by 1 over, which is the way the book shows it. So times 1 over Avogadro's number. 1 over 6.022 times 10 to the 23rd. Now if you look at the unit that's written down in the textbook, it shows molecules here on the bottom and moles on the top. That's because when you divide by a fraction, it's the same thing as multiplying by its reciprocal. So dividing by molecules per mole is the same thing as multiplying by moles on the top and molecules on the bottom. Alright, so now if I do this multiplication, I've got molecules on the top and molecules on the bottom, so that unit of molecules will cancel out. And now I'm at moles. But I want to keep on going because I want to get all the way to grams. So the next step says to get from moles to grams, I'm going to multiply by the molar mass. So I need to know what the molar mass of carbon dioxide is. So the molar mass of carbon dioxide is going to be the sum of one carbon, and carbon has a mass of 12.01, and 2 oxygens, and they have a mass of 16 each. So that should come out to 44.01 grams per mole is the molar mass for carbon dioxide. So here, let me multiply by that, 44.01 grams per mole. Now, I've got moles on the top, moles on the bottom. That means that moles will cancel out, and I'll be left with a final unit of grams CO2. Now here comes the tricky part, putting all this into your calculator. So I'm going to be working off of a TI-84, but the concepts are the same regardless of what calculator you're working with. So I'm going to start with my starting amount, which was the 7.92 times 10 to the 19th. Now on my calculator, the times 10 button is a double E secondary function. So just figure out on your calculator where the scientific notation button is. So times 10 is double E button, which gives me an E up there. So 19. So that means 7.92 times 10 to the 19th. So the first one is, now I've got 6.022 times 10 to the 23rd on the bottom, so I'm going to divide by that. Divide, not multiply, divide by 6.022, and then my double E function again to get that power of 23. Now the last step is to then multiply by 44.01. So I'm going to times 44.01 and hit enter. And there it gives me an answer of 0.00578. I only need 3 significant figures because I only started with 3 significant figures. So I'm going to round that last digit up to 9. Now, if it wants it in scientific notation, of course, you have to move that decimal. So 1, 2, 3 spots, or 5.79 times 10 to the negative third grams CO2. And that is your final answer. So this is how to go from molecules all the way back to grams.